Hello, welcome to Taxonomy Online Mathematics episode number 3 of Rate of Change as the application of differentiation calculus 3. The radius of a sphere is 6 centimeter and it is increasing at the rate of 0.25 centimeter per second. So at what rate in terms of pi is the volume of the sphere increasing? So the quantity mentioned here is volume of a sphere. So we need to know what is the volume of a sphere in terms of a formula. But before then, let's bring out the data from the question. The first data is radius. So our radius is 6 centimeter. It is increasing at the rate of change of the radius. That is, the r with the t is given as 0.25 centimeter per second. So you are looking for the rate of change of volume, right? That is what we're looking for. So dr over the volume, dv over dt, the rate of change of volume with respect to time is what you're looking for. But we can remember that volume is given by 4 on 3 pi r cubed. That is if you pick the volume of a sphere. This is the formula. So what are we going to do? We need to differentiate, right? So dv, dr, differentiation of v with respect to r, because pi is a constant. 3 come forward to multiply the 4 divided by 3. That will give you 4. Then pi will come, r exponent 3 minus 1 give you exponent 2. So we have our dv, dr. We also have our dr, dt. This is what you're looking for. So the next thing is use the chain rule. So using the chain rule, this is what we are looking for, which is dv dt equals to, we begin from dv, then the next parameter will be r. So dr times the same parameter divided by the dt. That is the chain rule, right? So now we have to check whether we are given this and this in the question. dv dr. dv dr. We know that as 4 pi r squared dv dr times dr dt, dr dt, which we have as 0.25. And 0.25 is going to be 25 divided by 100 in terms of a fraction. 25 into itself 1, into 100 4. So this is going to be 4 times 1 on 4. When this comes, you need to cancel. So I'll be left with only pi r squared with this multiplication. But we are looking for this in terms of pi, not r. So we can say that our r has been given to us in the beginning as 6. Therefore, your dv dt will be equals to pi times r squared, which will be giving you 36 what? Pi. So we're looking for. So the volume, we are looking for the rate. Therefore, so we can say the rate at which the volume is increasing is going to be 36 pi centimeter cube per second. That will be the final. If you multiply by the pi, you'll be able to get the final volume. But we are asked to leave it in terms of pi. Again, this also gives you another fair idea about the rate of change when it comes to the application of differentiation. Don't forget to share, like, subscribe, and follow us on Facebook. Leave a comment for us to know we are doing this together.